A pleasant day, everyone. Welcome once again to our discussion for today. So today we are going to discuss about the differentiation rules, but our topic for today will be more on the quotient rule. All right. So what is quotient rule in our differentiation rules? So if you're given f of x, so f of x equal to some function of x divided by some other function of x, then the derivative of f of x, the derivative of our function is simply we have some other function of x, which is the denominator. So denominator multiplied by the derivative of the numerator minus the numerator divided by the derivative of the denominator and divided by the square of the denominator. Alright? So if you're given this function of x equal to some other function of x divided by some other function of x, so the derivative of this is just, you look at the denominator, okay? So multiply this by the derivative of the numerator minus the numerator, this one, multiplied by the derivative of the denominator. Then everything, or the difference above, is divided by the square of the denominator. Okay, so that's the quotient rule. So for example, example number 1, if you're given, say, function of x equal to 2x plus 3 divided by 5x plus 1. And what is the derivative of this rational function? Okay, so using the formula or the rule, the quotient rule, so we have f prime of x equal to, so first we just copy the denominator. So this is our denominator. Okay, so we have 5x plus 1. Then multiply this by the derivative of the what? The derivative of the numerator. Okay, so this is our numerator. So what is the derivative of this numerator? So let's apply the power and sum rule. So we have derivative of 2x, so that is 2, okay, and derivative of 3, that is 0. Okay, then minus, this is the numerator. Okay, so this is the numerator. So this is our numerator. You just copy the numerator, 2x plus 3. Then multiply this by h prime of x. Alright, so denominator, or the derivative of the denominator. So our denominator is 5x plus 1. So what is the derivative of 5x plus 1? Okay, so using the sum rule, so derivative of 5x is equal to 5. Then plus derivative of 1 is a constant, so derivative of constant is equal to 0. And divided by square of the denominator. So our denominator is 5x plus 1, then squared. Okay, then simplifying, so we have f prime of x equal to, so we have 5x plus 1 multiplied by 2 plus 0 is 2. Then minus 2x plus 3. Then multiply this by 5 plus 0 is 5. Divided by 5x plus 1 squared. So f prime of x is equal to so let us distribute and multiply these two here. Let's distribute and multiply to each of the term in the quantity. So similar to this one. Okay. So we have 2 times 5x, that is 10x. Then 2 times 1 is 2, so this is plus, so plus 2. Then minus, okay, so don't remove yet the parenthesis. So we have 5 times 2x, this is also 10x. Then plus 5 times 3, so 5 times 3 is 15. Then divided by 5x plus 1 squared. Okay, so f prime of x, so we can simplify this. Now the numerator, let's remove the sign of grouping at the numerator. So 10x plus 2, we just copy this one. Then minus, so now when you remove the sign of grouping, you just multiply this negative, understood to have negative 1 here. So negative 1 multiplied by each of this term inside the quantity. So negative 1 times 10x, so this is negative 10x. Negative 1 times 15, so that is negative 15. Divided by 5x plus 1 squared. Okay, so f prime of x is equal to, we have 10x, we have positive 10x, we have negative 10x, so when you combine them, so that is equal to 0. So we have 2 minus 15, so this is minus 13, divided by 5x plus 1 raised to a power 2. Okay, so this is our answer. Alright, so do you have any question? So I hope it's clear with your class. So that's our first example. So for this part, I'll just give you 2 examples. Okay, so our first example is done. So let's proceed to the next example. Our example number 2. So here's our example number 2. So if you're given f of x equal to the square root of 2x plus 5, then divided by x squared plus 3. Okay, so our given function is a rational function. So what is our derivative of this rational function? So my advice, if you have this kind of function class, express first the term that contains the radical in terms of its fractional exponent. So our first step here is to change this first into rational expression. Okay, so I'm not taking the derivative yet. I'm just copying this one, and I'm going to transform this into rational with a rational exponent. So 2x plus 5, then raised to a power. So radical, this is square root, so it means that the index here is 2. So that is equivalent to a rational exponent, that is 1/2. So raised to a power 1/2, then divided by x squared plus 3. And that's the time that we're going to do the differentiation. So the derivative of the function is equal to, using the formula, what is the formula? We have the numerator. Okay, so just recall for our formula. If you have, say, f of x equal to some function of x divided by some other function of x. So to find the derivative of this, so f prime of x is equal to, you just copy the denominator. Okay, you just copy the denominator. So what is our denominator? So we have h of x, so just copy this, and then multiplied by the derivative of the numerator, so g prime of x, then minus the numerator, this g sub x, then multiplied by the derivative of the denominator, and then the denominator, h of x, then square it. Okay, so that's the formula. So we'll use that formula to solve this problem. So we have the denominator. Okay, so according to this formula, we have the denominator, which is x squared plus 3, then derivative of the numerator, so derivative of this, so this is a power formula, so we can apply the general power formula. So we have the derivative of, I will rewrite it this way, derivative of 2x plus 5 raised to 1/2 with respect to x, then minus, we have the numerator, that is 2x plus 5 raised to a power 1/2, then multiplied by the derivative of the denominator, or derivative of the denominator, which is x squared plus 3 and with respect to x, so with respect to x, and divided by the square of the denominator. Okay, so simplifying, f prime of x is equal to x squared plus 3. So the derivative of this, so what is the derivative of this? So we will apply the power formula. Okay, so applying the power formula, general power formula or rule, general power rule. So we have the exponent will go down. So this is 1/2. Then multiply this by the base, which is 2x plus 5 raised to the power 1/2, but this time minus 1. Okay, and then the derivative of this. So what is the derivative of this? Is our u. U to the n, derivative of u to the n with respect to x is equal to u to the n times u to the n minus 1 times the derivative of u. So what is the derivative of this? This is our u. So it means we have to take the derivative of this. We are going to apply the sum rule and the constant rule. So derivative of 2x is 2, right? Derivative of 5 is 0. So 2 plus 0. Okay? So 2 plus 0. Then minus. So just copy this. So we have 2x plus 5 raised to a power 1/2. Then times the derivative of this. So derivative, you have the power formula here, or power rule here, and then a constant rule. So derivative of the first term is just applying the power rule, so that 2 will go down, right? Then times x. Then x raised to a power 2 minus 1. 2 minus 1 is 1. So 2x to the power 1. So no need to write 1. And plus derivative of 3. 3 is a constant, so that is equal to 0. Then divided by x squared plus 3. Then squared. Okay, so simplifying. So f prime of x is equal to, we have x squared plus 3. Then this will be times 1/2 multiplied by 2x plus 5 raised to a power 1/2 minus 1 is negative 1/2, right? And times 2. So you have times 2. 2 plus 0 is 2. So you have times 2. Then minus. So 2x plus 5 raised to the power 1/2. Then 2x plus 0 is 2x, so multiplied by 2x. Then divided by x squared plus 3 raised to a power 2. Okay, so simplifying further. So take note that we have here a multiplication, right? We have 1/2 here multiplied by this. So 1/2 multiplied by 2. So what will happen? So this will just become 1, right? So what is left on the first term? So f prime of x is equal to, so you have x squared plus 3 multiplied by 2x plus 5 raised to a power negative 1/2. Then you have, so you can write it first here. So you have 2x times 2x plus 5 raised to a power 1/2. Then divided by x squared plus 3 squared. Okay, so you may simplify this one, or you may stop up to this part. But the good thing, if you are going to simplify this, you will be able to see the simplified form of this expression. Okay? Because, for example, if the exam is in a multiple choices or multiple choice, then you just stop up to this one, and then the choice is not it's not expressed on this form, so you will not be able to see the correct or the choices, because perhaps the choices is simplified. Okay, but I think if you will be able to do up to this part, so you'll have already a very huge points, huge credit for your work, for your effort to reach up to this part of your solution. Okay, so if you want to simplify this one, then actually you can bring this down. Okay, because this is a so you will have this becomes more complex, so I don't have to do that here because it will cost us a lot of time to simplify this one, but just try yourselves. Okay, but if you have any question, if you really want to see the simplified form of this answer, then you may send me your message. I'll show you the solution on how to do it. Okay, so I think that's all for this part. Our differentiation rules, specifically our quotient rule. Okay, so thank you very much, and I hope to see you again in the next video. And our next topic would be about chain rule. Okay, so stay safe and healthy, everyone, and see you later. Bye bye.